Dive into Mind Syrup, your sweet spot for science and technology enlightenment.
Have you ever pondered about the future of space travel? Let's take a stroll down memory lane. It all started with a single step on the moon, a giant leap for mankind, as Neil Armstrong famously put it. Since then, we've witnessed numerous advancements, from reusable rockets to the establishment of the International Space Station, a remarkable testament to human ingenuity. However, the journey to the stars isn't without its challenges. Current forms of space travel pose significant hurdles. The astronomical costs are prohibitive, creating a barrier to widespread participation and exploration. The environmental impact of rocket launches is another pressing concern, as is the inherent risk to astronaut safety. These are formidable issues indeed, but what if there was a way to circumnavigate them? A solution that not only makes space travel more accessible, but also safer and more environmentally friendly? Well, hold on to your seats, because we're about to introduce you to a revolutionary concept. But what if we could change all of that with a simple idea, a space elevator? Imagine a giant elevator stretching from Earth into the cosmos. This is the concept of a space elevator. A space elevator, as the name suggests, is a theoretical mode of celestial transportation, taking us from our home planet directly into the boundless expanse of space. But how exactly would this work? The design consists of three major components: the base station, the cable, and the counterweight. The base station, also known as the anchor, would be located on Earth, likely at the equator where the planet's rotational speed would provide the most support. The cable, also referred to as the tether, would extend from the base station, reaching far beyond our planet's atmosphere. This is not your ordinary cable, though. It would need to be remarkably strong and incredibly light. Now, picture at the end of this cable a counterweight. This counterweight would be positioned at a specific distance from Earth, a place known as the geostationary orbit. At this point, the gravitational pull of Earth and the centrifugal force of the counterweight balance each other out, keeping the cable taut and the system stable. But what could possibly be strong enough to span this cosmic distance, yet light enough to be practical? The answer lies in a material called carbon nanotubes. These tiny cylinders of carbon atoms boast a strength-to-weight ratio far superior to any material currently available and could be the key to making the space elevator a reality. However, we're still in the realm of theory. Despite their impressive properties, producing carbon nanotubes in the quantities necessary for a project of this scale remains a significant challenge. Yet, with technology advancing at an unprecedented pace, the day when we can step into an elevator and ascend to the stars may not be as far off as it seems. So a space elevator could be the key to affordable and safe space travel. But how would it revolutionize our journeys to the stars? A space elevator could completely change our approach to space travel. This isn't just a statement of futuristic aspiration, but an exciting possibility that could revolutionize our relationship with the cosmos. Imagine for a moment a world where the stars are not just distant specks of light, but destinations within our reach. The space elevator could be the key to unlocking this future. It presents a tantalizing prospect, a direct, reusable line to orbit that could drastically reduce the cost of space travel. By replacing expensive rocket fuel with the simple power of mechanical ascent, a space elevator could lower the financial barriers that have long kept space a playground for only the wealthiest nations and corporations. But cost reduction is just one piece of the puzzle. Space travel is inherently risky. Current launch methods involve strapping astronauts and precious cargo to rockets filled with volatile fuel. A space elevator, on the other hand, would offer a much safer alternative. By using a tethered cable system to gently hoist payloads into orbit, we could essentially eliminate the risk of catastrophic launch failures. The implications of a safer, more affordable route to space are profound. For one, it could democratize access to space, opening up opportunities for a wider range of players, including smaller countries, private companies, and even educational institutions. Moreover, it could also pave the way for a booming space tourism industry. Picture this. Instead of a handful of billionaires taking joyrides to the edge of space, we could have everyday people vacationing on orbiting hotels or even the moon. And let's not forget about the ultimate human dream, colonizing other worlds. With a space elevator, we could ferry the necessary materials and manpower into orbit to build self-sustaining habitats on the moon, Mars, and beyond. The space elevator could be a game changer, but what are the challenges we face in building it? As we navigate this exciting frontier, it's important to keep our eyes wide open to the hurdles ahead. As the saying goes, the sky is not the limit, it's just the beginning. Building a space elevator is no easy task. It's like trying to construct a tower that reaches into the heavens, a concept that seems almost mythical in its grandeur. Yet this monumental endeavor poses challenges that are very real, very tangible. The first challenge is finding a material strong enough to withstand the immense forces at play. We're talking about a structure that spans thousands of miles, from the surface of the Earth to the cold emptiness of space. The materials we commonly use in construction today, like steel or concrete, simply won't cut it. They are either too heavy or not strong enough. What we need is a material that combines the lightness of a feather with the strength of a diamond. While no such material exists yet, scientists are hard at work researching new substances, like carbon nanotubes and graphene, which show promise. Next, there's the risk of space debris. With thousands of satellites and a smattering of miscellaneous space junk orbiting our planet, the elevator would need to withstand or avoid potential collisions. It's like playing a cosmic game of dodgeball, where the stakes are astronomically high. Again, it's a problem without a clear solution yet, but experts are exploring various strategies, from advanced tracking systems to protective shielding. And then, of course, there's the cost. Building a space elevator would require a financial investment that makes the Apollo moon missions look like a weekend getaway. It's a price tag that could run into the trillions of dollars. But then again, the potential rewards are also colossal. A functioning space elevator could drastically reduce the cost of sending payloads into space, making it a long-term investment with potentially huge returns. The space elevator is an exciting concept, and though it poses significant challenges, it also holds the promise of a new era of space exploration. Like all great feats of human ingenuity, it's a challenge that tests our limits, but one we are determined to overcome. As we look towards the future of space travel, the space elevator presents a tantalizing possibility. We've delved into this intriguing concept, its potential to revolutionize space travel, and the challenges that lie ahead in its construction. It's a path laden with technical hurdles, but the rewards are monumental. So as we gaze up at the stars, we can dream of a future where a simple elevator ride could take us there. Until then, keep exploring, keep innovating, and keep looking up. The future of space travel is just over the horizon.
Cherish knowledge, give a thumbs up, hit subscribe, explore science and tech.